Hello there, it's Alana, and I'm back to help you with 6.1, number 18 from the textbook. And this is another T one. So I've assigned the technology one for my students. There's another one that doesn't have the technology piece, but it should work very similarly. Okay, so we have a following probability distribution. The random variable x represents the number of activities a parent of a 6th to 8th grader student is involved in, and so on. And I'm going to click, sorry, to do the example. Oh, they changed it to a K to 5th grade student. That's fine. Okay, so the parent can be involved in no activities, one activity, two activities, and so on. So the first thing we've got to do is copy this to a clipboard, shall we? Don't put it in StatCrunch for many reasons, but not the least of which is we actually can't use StatCrunch to do what we need to do here. All right, so verify that this is a probability distribution. To do that, what you need to find is the sum. So equals sum of these probabilities. And there we go, the sum is 1. The other issue, there's 2 steps to noting that it's a probability distribution, by the way. One of them is the sum, that it adds up to 1. A couple of things with that. One, it sometimes can go to like 1.0001 because of some rounding issues, and usually that's okay. The other issue is that every probability here has to be between 0 and 1, right? So that's the other piece of it. And we have that. So it's both of those pieces together. So you have to have each probability between 0 and 1. Technically it's inclusive, but we don't really care. And the sum of all probabilities is 1. And again, sometimes 0.99999, whatever, it happens. Okay, so that's that piece. I'm just going to kind of put it down here somewhere. All right, cool. I got that part. And then what do they need? A histogram. And then they want the mean and all that good stuff. Okay, so a histogram, we learned about finding and drawing those in chapter 2, if you'll recall. Just highlight the probabilities. Don't bother with the rest of it. I'll show you why. So if you highlight the probabilities, click column. Don't do the total, by the way. That's bad. Only do the probabilities themselves. And I like to grab the title for no good reason, apparently, because it didn't actually do anything. But I can say this is a probability histogram. Ooh, and it's part B. I'll put that in, part B. Okay? And then you can fiddle around with the labels if you want a label and all of that, like the vertical axis is probability and stuff like that. It's kind of not important, but what is important is that you change these. So what it does is Excel goes first category, second category, third category, fourth, and fifth. But that's not really appropriate because we want that first one to be 0, 1, 2, 3, 4. So what you do is you kind of click down here on these numbers, you right click, select data. Actually, I don't think I had to click on the numbers to do that, but anyway. And you see the horizontal category axis labels. They're currently 1, 2, 3, 4, 5. We want to edit that. And we want 0, 1, 2, 3, 4. Don't get the X. You don't care about the X. Just 0, 1, 2, 3, 4 and say OK. Now it's listing those 0, 1, 2, 3, 4. And you can see beneath me that the categories changed. Technically, histograms should touch. So if I click on a bar, right click, and format the data series, the gap width should be 0, technically. And you can also fiddle around with colors and designs. You can make it, prettier, do whatever you want. Okay, so there's your histogram. Beautiful. And then you look for whichever histogram matches that. To be honest with you, you don't really have to draw it to figure it out. You can kind of look. Usually they give you multiple choice, so you can kind of see which one it must have been, but that's okay. So our histogram looks like that histogram. It's just our histogram is prettier. Much prettier. All right, then they want the mean, and I bet you they're going to want the standard deviation too. Sure enough. Okay, so let's go back. We can find both of those at the same time. So the mean is actually not hard to find at all. Because the sum is always 1, this is actually a technique we learned in section 3.3, but it's even easier here because we don't have to bother dividing. It's just the sum product of that array of x's and this array of probabilities. Enter. There's your mean. Diggity done. As easy as that. Don't believe me? Well, there it is, 1.369, just like they said it was. Okay, so that is the mean. And again, in this chapter, it's super easy. You just find some product, you're done. In chapter 3, you had to find the sum product and then divide it by the total, and that would be the mean. It's just that the total here is 1, so you never have to bother. Cool. All right, now there are a couple ways we can find this part. I'm trying to think. All right, let me do it this way. So I'm going to find x minus the mean. I'm going to give the mean dollar signs, and then I'm going to square it. So let's do it that way. Let's see if this works. Equals, parentheses, that value, which is A2, minus the mean. And mean has to get dollar signs because I need it to not change. I need it to be a fixed reference. And enter. And now when I drag it down like that, it'll automatically, right, see, look, it kept the 1.369 but moved the 1 down. And then it keeps the 1.369 but moves it to 2, and so on. Okay, so now I'm going to find the total here. Oh, actually, I don't need the total there. I need the sum product because I need to multiply each one of these times their probability. So I'm going to find the sum product. Let me put it right here. Equals sum product. Okay, and I need this array, which I just found, the x minus the mean, comma, the probabilities that go with them. Okay, so that's the sum product. And then we would normally divide it, but we don't have to because you'd be dividing it by the total of the probabilities, which is 1. So this is really the variance, if I'm not mistaken. And then the standard deviation would be equal to the square root of that number. There we go. Let's see if I did it wrong. Nope, I did it right. So that's how you do it. And they wanted to round to 1 decimal place, but that's stinky. But that's okay. So if you rounded it, format cells, number, I only want 1 decimal place. That's what it would be. It's kind of lame. But so the sum product is, by the way, equal to the variance. And again, that wasn't the case back in chapter 3. In chapter 3, you would actually take that sum product and divide it by that total right there. But the total in this chapter is always 1 because probabilities have to add to 1. So it's no good to you. Okay. And by the way, just on the side note, this is sigma. This is the population standard deviation. Let me just make sure that's clear. Population standard deviation, which is sigma. I'm going to even insert the symbol for it. Okay. The reason being, technically, we're supposed to know the population because it's a probability distribution. Probability distributions are automatically considered to be a population. Now, we know in real life when working with data, that's not the case. But when you're working with a population, i.e. a probability distribution, then it will be the case that you know mu and sigma. Normally we don't know mu and sigma for most problems. Occasionally we do. But here in probability land, you always know it because probability is how it will work forever in the future, which is, hypothetically speaking, all probabilities, all future, the whole population. All right, so the mean, population standard deviation, you have to do this elaborate thing that we learned from chapter 3 and we learned again in chapter 6. You cannot just say, find the mean of these numbers, find the mean of these numbers. That won't work. You have to work in concert. It has to be the sum product and then the sum product square rooted for this thing. And then for the standard deviation, you have to go to this elaborate finding the x minus the mean and squaring it first. And keep in mind that sum product is kind of backwards. You actually want this blue box, the x minus the mean stuff, to be your first array, and this green box over here to be your second array, the probabilities themselves. Okay? And you don't have to bother with the division. I just threw that in there because you're always dividing by 1 because you always have 100% of your population accounted for because it's a probability distribution. All right, so we found the mean, we found the standard deviation. What else do they want? What's the probability of selecting a parent who's involved in 3 activities? Well, that's kind of lame. And then 3 or 4. Okay, so this was part, I better put these in. This was part C, I believe. And over here was part D. Okay, now part E is right here. I'll kind of put it in blue. That's part E. I'm going to skip over that middle part, but there it is. So the probability of 3 exactly, I guess I could throw it down here. Let me do it here. E is equal to this value right here. There. And then F was saying 3 or 4. Well, 3 or 4, oh, I better, This was the probability of 3 exactly. And this is the probability of 3 or 4. And of course, we've learned that OR is an addition rule problem, right? So what we're going to do is we're going to add up 3 and 4. So it's equal to the sum of 3, comma, 4. There we go. And there's that one. I'll make it purple. Ah, that's too dark. You can't see that. That purple. All right, there we go. A is a little out of order, but that's okay. It won't hurt anything. All right, I think we've finished the whole problem. So, yep, we're done with all of it. So remember, the hardest part of this is to find that standard deviation. That's the worst, right? You first find the mean with the sum product. Don't need to divide in this chapter because it's divided by 1. And then you got to do this whole elaborate thing with the dollar signs for the mean, square it, right? And then you find the sum product again, but this time with this guy as the first array and the probabilities as the second array always, because your probabilities are your weights. You don't have to bother dividing like we did in 3.3, and then you just take the square root of it. And that'll be your population standard deviation, which let's not forget is x, or excuse me, I'm sorry, which is sigma. I apologize. All right, I hope that helps.